Hello and welcome to IEEE Soft Robotics podcast. In this podcast, we're going to interview researchers from both academia and industry about their work, thoughts, spectrum, and more beyond that. This is Marwa Edwini, and I hope you will find this podcast useful. If you would like to connect with us, simply send us, and we will be happy to hear from you. And here is my interview. Thanks. Hello and welcome to IEEE Soft Robotics podcast. Hello, Brian. Thanks so much for joining us in the podcast. I would like to ask you how you would like to introduce and how you would like also to define yourself for the audience who first time listening to you.
Yeah, of course. Thanks for having me, Marwa. I am the construction technology manager at Boston Dynamics. I have worked in the AEC industry all of my career, kind of transitioning from design technology for an architecture practice to construction researcher, and then ultimately to a product manager for the Spot robot, working directly with the AEC industry. So spanning from architects to general contractors to real estate professionals to really help them better understand how to get value from robotics on job sites.
So we ask all the time a signature question about childhood. I don't know if you have any kind of memories about your childhood, being interested in science or tech in general, if you have any memories about that.
Yeah. The story I always tell about how weird I was when I was a child was a lot of architects have stories about designing with Legos when they were children, and that built up a love of construction and design. I have a Lego story, but it was that I really liked to sort and taxonomize my Legos. So I like to dump all the Legos out and count how many colors and shapes of each Lego I had, and then understand every possible combination of 2 Legos and then 3 Legos and just lay them all out. So a very bizarre way of playing with Legos, but it kind of it shows my interest in understanding systems as a whole, and how over my career I've kind of migrated from being focused on the design to thinking about the broader systems of building delivery and how we can build inefficiencies there. That's really ultimately what led me to robotics, because I thought that's where there would be the most impact at a systematic level.
That's very interesting. I'm curious to ask you in this regard, do you think the designing process, what kind of thoughts come to you when you design something, just maybe bizarre on you? It's kind of intuition, you follow your intuition, or how what's the process for designing in general?
When designing, let's see, I went to architecture school and I worked for Woods Bagot, an architecture firm, for a while. So I was in the design space. I also taught architecture courses at Pratt. I always struggled with the design process because you have to ask the question and you have to answer the question. A lot of designers will tell you that the more constrained the design problem, the more creative they can be. And I really relate to that. It's tough to, that's really what pushed me to the side of, well, I'd rather analyze, the design problem. I'd rather take that and focus on a very specific and constrained problem. So for example, when I was at Woods Bagot, I wasn't designing the shape of the building. For me, it was too under constrained, right? One client might want a twisty building and another client might want a round building and another client might want a square building. I'd rather focus on taking whatever arbitrary geometry the designer came up with and then using algorithms and design computation to rationalize that building design for fabrication and construction. That was a much more constrained and hard-coded problem that I felt more comfortable with. There are things that I miss about being a designer. Certain types of geometries I was really attracted to and inspired by. I have a long history with, I've actually used 3D NURBS modeling with Rhino since I was 14 years old, because it just happened to be taught in my high school. I've always had a love for the kind of sinuous curvature of NURBS geometry. And, on the other side of NURBS, the fact that you could use that particular geometry type to directly drive manufacturing operations, such as CNC tool pathing and machining. So there are things I miss. about that kind of more creative side of the process. But I've certainly ended up focusing more on the, I would say, analytical side of things later in my career.
So I'm curious how you become involved in the Spot Boston Dynamics. How it's happened to you that you be involved in this side, and was it challenging for you? If you can tell us a story how you became involved in that, yeah.
Yeah, of course. I was a construction researcher at WeWork, and we were looking for ways to capture data on our job sites. We had acquired some general contracting companies, which meant that we were vertically integrated in the sense that we were both the architects of a space, the owners of a space, and the builders of a space. So we wanted to have better information on the status of our many projects that would be happening concurrently across cities like New York and San Francisco and London. We were having trouble getting that data with manual means. So we wanted to try to automate that with robotics. It seemed like a good idea because, one, people aren't particularly good at regular and highly kind of accurate and repeatable data capture. If I'm walking around a job site holding a camera, am I going to stand at the exact same spot at the exact same time every day? Probably not. Also, is that the best use of my human capabilities? Probably not. So that seemed like a great place to insert robots and automation into a construction environment. We started with looking at all the different types of robotic locomotion that would be available for that, because it didn't really matter what you were doing with the robot, right? Whether it was some kind of sensing like photography or laser scanning, or some type of manipulation or actuation on the environment, if you couldn't move through a dynamic construction environment. So we looked at drones, which are highly popular for exterior and overhead data capture. There are a lot of safety and operational shortcomings of drones in indoor spaces. So that was kind of crossed off the list. We looked at wheeled and tracked vehicles, which could get, which could get through flat ground areas, but really struggled with dynamic obstacles and failed on things like stairs for vertical construction sites. So still couldn't get everywhere, turning radius issues, all sorts of things. So then I used to think that legged robots were too exotic for construction and industrial uses. And then in, what was it? I think the spring of 2018, sometime in 2018, Boston Dynamics released some videos of the alpha Spot robots on Japanese construction sites. And I said, well, maybe that's not too exotic. Maybe it's time we called Boston Dynamics and tried this out. So we became an early adopter customer and piloted Spot on our sites. We were looking to answer a few questions. One is, can we have a machine that moves autonomously through a typical construction site? We were able to do that. Can that machine capture data repeatably of our construction site? We were able to prove that out. And then lastly, can we take that data, because it doesn't matter if we have lots of data, right? We have to be able to do something with it and make that actionable. So can we use the Spot SDK and connect that to our construction management software APIs? At the time, this was FieldLens at WeWork, and also leverage a connected job site to send that data over a job site network to the cloud, such that that data was available for further processing by our team. And we were able to check that box off too. It was hard work, but we were able to really tick all of the boxes in this proof of concept early adopter exercise. And that's when it really struck me that legged locomotion was really going to be the way that we were able to bring automation into human purposed environments such as construction sites. So then I knew that the way I could have the most impact on the future of the construction industry was to join the team at Boston Dynamics.
That's wonderful. Yeah. So maybe I'm curious at the beginning, were there any challenges you faced when you try to incorporate Spot in the construction environment? Since you mentioned example or comparison to wheeled legged robot, for example, but were there challenges you faced to work with Spot or limitation? Because we know there's limitation in the current release, but what kind of made challenging for you at the beginning?
Oh yeah, I mean there were hundreds of challenges in a construction environment. I mean, one of the things I always say is, a construction environment is arguably the most difficult type of environment in the world for automation. You have a dynamic environment in the sense that there are both people and equipment moving through it. It's a temporal change as well, in the sense that if you're using perception systems for autonomy, they have to account for the fact that the environment changes every day and is temporary. And then, of course, your terrain is very challenging as well. You go from, you have dirt, you have gravel. Sometimes you have a nice, clean concrete floor, but you also have dusty concrete floors, or you have dust that's mixing with water that creates a sludge, or you have ice, or you have tools or cables or things that have been laid out on the ground, or just, all sorts of things that can lead to slips and trips and challenge any kind of mobility system. So yeah, needless to say, the robot fell down quite a bit when we were first testing it. This was back in 2018 and into early 2019. But that was really the point of Boston Dynamics working with those early adopters, was to tweak the parameters of the underlying software. The hardware of Spot is incredible, and there's so much more performance that remains to be unlocked through software updates. Even in the few weeks of doing some of those proof of concept exercises, now 2 or 3 years ago, we saw dramatic improvements, to the point where now sometimes I'm with customers on site, and even when they try to make the robot fall down, they're unable to do so. We have a lot of customers now who are able to take the robots into terrains where there's potential hazard to a human worker, which is, I think, a really incredible advantage of a robot. So if you think about corrugated metal decking or rebar grids, these things that are laid down prior to pouring concrete for reinforced concrete slabs, they're pretty tricky to walk on with your construction boots, and they can lead to trips, and they can lead to injuries, which you don't want. So to have a mobility system that's able to walk through that essentially fearlessly, and that means that you can capture critical data in that environment, not put human workers at risk, and it's hard to put a price on that. But yeah, lots of challenges. I'm talking just about mobility and terrain, but I also alluded to the fact that perception and autonomy is a huge challenge in this space. If you have a fixed environment, a building that maybe you're a real estate professional or owner or an operator of a building, and you're going through and tracking assets, or you're an industrial customer in a fixed industrial environment where, there are some things that are changing, like people and equipment moving around, but most of the equipment is fixed. Most of the rooms and spaces are fixed. That's a much easier environment to map and to navigate and to perceive than one that changes every day. How does a robot know on a construction site that an open demoed environment is in fact the same environment once all the walls go up? These are problems that are sometimes hard for human workers to perceive, let alone a robot.
That's a great, yeah. Maybe a quick question here, Brian, about the limitation, because this is really world's most advanced autonomous legged robot. But maybe the question about the limitation, how do you think maybe about this tackling the limitation, or do you think it's still missing pieces? You think maybe can be incorporated in future version of a Spot for construction environment? Do you have any kind of thoughts what it's still maybe missing, or you think, could be incorporated future generation of Spot?
Yeah, I mean, my answers tend to focus more on the software side. How do we get more performance out of the hardware? Because I'm not a robotics hardware expert by any means. I work with them, but I myself am focused on what is the use case, how does this add value, and how do we further develop software and products that extend the usefulness of the robot. We have a few things coming out right now that are really intended to do that, both on the hardware and software side. One is we've introduced self-charging. So first and foremost, if the value of the robot depends on autonomy, then replacing its battery every 90 minutes isn't really full autonomy, is it, right? So we're always working toward that goal of reducing required user intervention, because the more the robot is able to operate on its own, the more value there is. The other thing, and perhaps the more critical thing about a self-charging dock, is that means the robot is always on. It's always ready to respond to human input and command and do something useful. It doesn't need to go, it doesn't need to be turned on. It doesn't need to be transported into the environment. It's part of the environment. It's ready to act on that environment. We're also releasing the arm, which adds manipulation capabilities to the sensing capabilities. Right now, the focus, at least in the construction industry where I really serve, is data capture. So it's all about putting sensors on the robot. Those could be image sensors, those could be laser scanners, those could be environmental sensors for illumination or silica dust, those could be thermal cameras, those could be RFID and BLE readers for material tag tracking. You know, the list is pretty limitless, and there are a lot of needs for data capture in that environment. That's what we're really going to tackle and master first. But obviously, at some point, there's a lot of advantage to being able to manipulate and interact with the environment as well. Even simple things like a door is closed and the robot needs to open it, or there's a hanging cable in the way and the robot needs to move that out of the way, or there's a small object that maybe needs to be, you know, moved across the site. There are all these opportunities, even before you get into actual construction tasks, which remains to be seen how useful Spot is in that context, you know, and that's really where you see a division between generalized mobility platforms like Spot, something that's able to carry sensors to any location in this environment, and task-specific robotics. A really great example is Dusty Robotics, which has a layout robot that's essentially a printer for the ground that prints the lines where walls and other architectural elements should go. It does that really well. That's the one thing it does for now, but it does it really well. It acts on the environment to achieve that task. So I imagine that in the future, there will be many different types of robots. But back to your question about improvements with Spot, and what we see is, I'm really interested in the ability to have both repeatability. For example, the robot walks the same exact path every day, does the same things, and captures the same data, combined with flexibility, of course, because you think you want that, and then you realize that the site is obstructed or the site has changed and you need to react to that change. Humans are really good at this, right? We go into environments and, you know, if somebody is walking their dog down the sidewalk and I had only ever seen an empty sidewalk before, that's not a problem for me. You know, I can move to the right or to the left and continue to walk down the sidewalk. So it's that level of change. And it's also the fact that, well, now there's a new wall here and I have to plan a completely new route. So I think advances in autonomy that allow for better decision-making about routes and alternative planning when the site changes, that's really where I see a ton of value being added. The issue there really is about the concept of operations and safety protocol in these environments. There are things we can do technologically with the robot in terms of it making its own navigation decisions that we might not want to do, because you need to socialize robots on site and everybody needs to have an expectation of what is the robot doing and where is it going. So at the moment, there's a safety corridor. If you plan a path for the robot, it's really not going to deviate from that path by more than a few meters without asking you permission, asking for your oversight, because maybe you didn't consider a robot going into that area of your site and maybe there's a problem with that, right? There's nothing more important than safety. So one of the things we are figuring out with customers is, can the robot go anywhere in your environment? How do you give it the semantic understanding to be able to make really smart decisions to move around this dynamic environment, but also to know where it's not safe to go, because maybe you're installing an exterior wall and there's an open slab. Maybe there's an area for the staging of materials, or maybe it's an area with high human activity. These are things that by and large exist in a lot of kind of AMR offline path planning softwares. Those machines are obviously less sophisticated without the legs and some of the perception systems required for a construction environment. So there's software precedent for this. It just needs to be combined with the unique capabilities of legged locomotion in the unique dynamic environments like construction sites.
Also a question for the audience, we can even read research as well. So thank you for that. We have a question from the audience. First one from Nathan, I think, from Georgia Tech. And he said that up till now, Spot has been mostly used to survey and record work sites. What are some of the big manipulation tasks you see Spot News are being used for? And where do you think the ARM will add most value to a construction environment?
Yeah, so the ARM, to be candid, a lot of the initial use cases for the ARM tend to be in environments where there are hazardous areas where you don't want to have to send personnel in. Examples of this could include obvious ones like a radiated environment, like a nuclear power plant, or even in Chernobyl, where Spot is doing inspections and might need to manipulate something. You have to have the ability to remotely manipulate the environment. But there are also other examples, like a regular power plant where normally you would have to de-energize an area of a substation in order to perform mandated inspections in that area. Well, what if you didn't have to do a shutdown? What if you could send a robot in instead? You could keep that environment energized and send a robot in knowing that you're not posing risk to a human worker. That could pay for many robots just in one exercise in terms of the value there. So on construction sites, the value of the ARM is perhaps less clear because people are really driving the use of the robot in those environments for data capture. And while there are hazardous environments and hazardous terrains where the robot can go, the point of sending the robot in there is still primarily for data capture and not for manipulation. Now, that said, the customers are, suggesting certain use cases. One that I think is interesting is, again, this idea of performing layout. Is the robot precise enough to use the ARM to mark the job site, to essentially draw the lines where walls and MEP and things like that go? We have a partnership with Trimble, which is a construction software and hardware company. They have a lot of knowledge about this industry. We are working with them to offer integrated solutions for laser scanning with their X7 laser scanner, as well as exterior job site autonomy with their GNSS smart antenna, the SPS 986. But we've also looked at some of their total station technology. So this is a piece of surveying hardware that really gives you like millimeter level precision, both to measure where things are placed with lasers, but also to mark out and indicate where things should be placed. So what you're doing is you're connecting the design model and the documentation, the blueprint, so to speak, or BIM, to the physical environment to correlate the exact location of things such that all of the trades and components are coordinated correctly and everything fits together as planned, and you deliver the job on budget, on time, etc. So the ability to perhaps combine in the future something like total station interior positioning technology with Spot's mobility and Spot's ARM for marking shows, perhaps this robot could be used in layout operations. So that's just one example. I think another one is materials conveyance or materials handling. Tool fetch comes up a lot. The idea that you have to walk long distances across sites to grab a particular tool to do your job. So the idea that you could have a system where all of the workers could, pull out their phone and make a request for items, and Spot could go grab those items with its ARM, perhaps place them in a bucket or a cart on its back and take those to the workers, I think is an attractive idea. So we're in the very early days of exploring what the capabilities are there. And I think just as with the core product of Spot itself and the various perception payloads we've experimented with and developed, we have a lot to learn from the customers themselves, right? We try to stay humble. Yeah. I'm from the construction industry. I have a background in this and some expertise in this, but there's so much to learn from the customers and the problems they're facing to really understand where this ARM and manipulation will provide value beyond the better understood use cases in industrial environments.
That's a great point. And we have also a question from Art Potter. He is from high school and he's just interested in the development of robots. He asks us, how long do you think before a Spot-like unit become most effective, cost effective? And is it a matter of time, or are there major hurdles to overcome the unforeseeable future?
Yeah, I think there are two components to making the robot cost effective. One is to continue to drive down the cost of the robot. That's really what will spur mass adoption. I think we've done a good job of creating some aggressive pricing for the initial sales offering, but the more we sell, the more we'll manufacture. The more we manufacture, the more those prices will come down. So recently, Hyundai took an 80% ownership stake of Boston Dynamics. We're very excited about that because one of the most obvious advantages of a partnership like that is access to intelligence around supply chains and opportunities around supply chains and manufacturing. So we'll see that as driving those costs down. The other side of it is providing ROI for our customers, right? Solving problems for them that saves money for them. There are examples where the savings are very obvious, as I mentioned before, the ability to send a robot into an energized area of a power plant to perform a mandatory and routine inspection without needing to de-energize that area is a home run. The ability to send a robot into a radiated environment to perform nuclear inspections and keep human workers out of harm's way. These are things where the value is just so obvious that you don't even really need to think about it for that long. On the construction site, it tends to be a bit more nuanced. Sometimes there are these situations that arise where you can remove people from hazardous situations, which is invaluable. But oftentimes what you're trying to do is you're trying to build a better data capture program and then leverage that data to make better, smarter, and more efficient decisions as you manage the complex construction and delivery process. Mm-hmm. A really great example of where customers see ROI that may not be so obvious, and really how they decide to become a customer of Spot, is the story of Swinnerton, which is one of our general contractor customers. So Swinnerton had been putting a lot of emphasis into paying their subcontractors more quickly. One of the problems of the construction process is there's a general contractor who is ultimately responsible for the delivery of the construction project, but they are subbing out a lot of the trades or all of the trades to other companies, which also means they have to manage the contracts and payments to those subs. If those subs aren't paid on time, that obviously causes problems and can delay the whole project. But it's also hard to know when to pay people, because people are typically paid based on how much work has been done. Well, how do you even know how much work has been done? It's really hard to track that progress. So they thought, there's a lot of value in being able to pay people on time. One is it will incentivize the subs to put in more competitive bids, because knowing that you get paid on time might make you charge a little bit less to do the work, because you won't have to deal with those extra problems and inconveniences on the kind of administrative side. It might also incentivize the owner to pay a surplus, right? You could charge a fee essentially for that. You say, hey, we are a builder who can really manage the books efficiently in a way that differentiates us from other general contractors. So it's one of those rare moments where you're really incentivized on both sides of things to do a better job. Well, how do you automate payments? You have to automate the tracking of how much work has been done. And how do you understand how much work has been done? Well, again, you have to have a robust and preferably automated data capture program. Mm-hmm. That is what led them to Spot. So I think that's a really cool story, because oftentimes what you see when you're moving advanced robotics out of the lab and into the real world is you've got a really amazing technology in search of some kind of problem to solve. How does this thing provide value in the real world? In this case, it started with a business problem, and then Spot was essentially derived as a solution to that. So I think that's a really great illustration of where we're at in that timeline. Now, in terms of the hard numbers on that ROI, there's a lot of work that remains to be done there. We are seeing significant time savings to perform certain tasks. So you can do these perhaps oversimplified labor hour calculations where you say, I was able to free up labor at this particular rate per hour to go do higher value tasks, and I can put a number on that. I think that can be a little bit short-sighted. It's important to understand those primary time-saving ROI metrics. I think the real ROI is in the secondary opportunities of what can you do when you have really clean, large data sets. You can use algorithms to process them and give you real-time actionable information for the next day. You can better understand how to stage and staff your site. You can better understand what problems need to be addressed before they balloon into even bigger problems. And you can actually start to use machine learning and computer vision techniques, because those rely on clean, well-annotated data.
Yeah, that's really also excellent point you said. And I think also one of the questions I think many students ask, how can someone get a Spot Boston Dynamic? And they have concerns how you make sure that when you sell it, or just make sure the technology behind it is really protected. So I don't know if you can answer that, how someone get Spot Boston Dynamics and how you make sure the IPs are protected as well.
Yeah, so, the robot is for sale. So I think it's really interesting that we have e-commerce for legged robots. I think that's really cool. So you can go to shop.bostondynamics.com. If you want to discuss your application in the construction environment with me, you can find myself, Brian Ringley on LinkedIn, and we can have that conversation. Or if you're from another industry, I'd be happy to connect you to my colleagues who specialize in other industries like oil and gas, manufacturing, logistics, et cetera, depending on what you're trying to do with the robot. So it is for sale. It started for sale in North America and has been progressing in more and more countries. We got CE marking in the EU, which opened up sales in Europe, which was pretty big. So there are a lot of places where you can get it. Generally, we can say that we put really robust protections in place to protect that. We have confidence in those systems, and we also have user terms to make sure that the robot is used in appropriate ways. For example, it is explicitly prohibited to weaponize the robot or to use the robot in an unsafe manner. But we work closely with all of our customers to make sure that the robot is being used appropriately and to add value. And, we haven't had a lot of issues with that. And then on the other side as well, we offer privacy and data protection to the highest standards for all of our customers.
Yeah. Well, thank you for highlighting that. Yeah. And also one of the interesting aspects about collision and the faults, or maybe we speak about limitation here. And for sake of safety, this question, do you think maybe soft robotics or artificial muscle could be incorporated for the designing process in the future to make sure it's safe and you don't have to make a distance like 2 meters, for example, as in available for description? So I don't know if that's something you thought about with the team, how we can make it more safer to interact with human directly, like soft robotics or artificial muscle.
Yeah, I think it's a good question. We get the question about the robot's ability to work with humans and, whether you'd call Spot a robot or a cobot. As it stands today, there is the aforementioned 2 meter distance. Spot is an industrial robot. Sometimes it will slip or it will need to make a mobility decision within a radius that would not exceed 2 meters. So that's really what drives that safe distance. The other reason behind that is, Spot has perception systems. So if you're standing right next to Spot all the time, it's kind of hard for Spot to see what it's doing.
Yeah.
Beyond that, cobotics proper, right? If you think about like a universal robot arm, if you're assuming that a human is working side by side with a robot, then that robot has to be able to run into that person or bump into that person. So Spot is not a proper cobot in that sense. You shouldn't be touching Spot or be right next to Spot when the motors are operating. That said, Spot can work in environments that are dynamic with lots of people moving around because its perception system will detect them and it will pause or navigate around them as necessary. So the question about whether soft robotics could be introduced, I have no idea. Again, that's kind of a future hardware problem. I think that in the near term, we're going to be sticking with this particular hardware set for a while. A lot of this stuff is the result of 30 years of research and development by Boston Dynamics to get legged mobility to be as dynamic and responsive as it is today, to the point where we can release dance videos with all of our robots. That is software and hardware dependent in a kind of synergistic relationship. So, but that said, there are general advancements in robotic hardware overall. And I think there are some really interesting areas, such as soft robotics, that could be useful in the future. We're always keeping our eye on that sort of thing. But I would suspect that for now, there won't be any fundamental hardware changes in the near term because the focus is going to be on unleashing further capability through the software.
Great. So come back to the obstacle avoidance limitation. Maybe what could be the greatest limitation or maybe still unsolvable dilemma for obstacle avoidance?
Unsolvable dilemma. Ooh, it sounds so dramatic. I think that, that's a great question. I don't think there's anything totally unsolvable per se. I mean, it's not so much about the perception of obstacles, it's about the behavior once the obstacle is perceived, right? How can the robot move around dynamic obstacles, which could be people and or equipment, in a way that is predictable? Again, part of that socialization of robotics into human purposed environments is these movements should not be erratic or unpredictable or confusing to other human workers on site. So how do we give the intelligence or capabilities perhaps to Spot to move around these situations in more predictable ways, to be safer, to be more responsive and flexible? I think that's really where we're at. And in terms of like an intractable problem, I mean, there are some tough robotics perceptions out there. You know, there are a lot of construction sites that get covered in snow and ice. You know, it's very slippery. How does a robot walk on ice in a dependable way? There are times where there are pools of standing water that create perfect reflections, which essentially creates a double world in a robotic perception system. There are tarps that are laid across equipment and materials on construction sites that blow in the wind. So you have both something that is reflective and moving around and taking up space and is soft when stepped on, right? How do you create better semantic understandings of everything, both in the sense that this isn't an obstacle, this is specifically a fire extinguisher, this is specifically a toolbox, or if you step on an empty box, that box will collapse. Whereas if you step on something more rigid, that will support the weight of the robot. I think those are the tougher problems. And, you know, some of them are more solvable than others in the near term.
Yeah. Thanks for highlighting this point. Yeah. So yeah, closing to the end, I have a few questions. First one is, why the translation from robotics, of robotics to industry is so challenging? And we have the question, why we don't have yet a useful autonomous robot? But I think Boston Dynamics is the first example that we are very proud of the advancement we have seen so far. But do you think in general, is it because about the manufacturing process or modeling? And where do you think maybe the missing pieces here or the breakthrough is missing, do you think?
Yeah, I mean, there's kind of a fundamental distinction I think I draw between environments that are fixed and robot purposed and environments that are dynamic and human purpose. So we're seeing some incredible advancements in the logistics industry. Think about something like Kiva Systems, which was acquired by Amazon and became Amazon Robotics, and this kind of continuous progression toward lights out factories and warehouses, where everything could potentially be automated, but the environment itself is just designed to be an entire machine, basically, to accommodate that automation. And then you have environments like construction sites, which will never be that way. There are humans moving around. It's one of the most complex environments in the world. So the reason that there wasn't useful automation in those environments for so long was just because the environment was too dynamic. There was no way to, there wasn't a lot of value bringing in fixed systems, camera systems, fixed sensor systems, et cetera, because it's a temporary environment. So you don't want to invest in a lot of technology for something that is being constructed, right? That is temporary. And then if you try to bring in mobile solutions, again, just like I was describing when I was at WeWork, you run into these issues of the capabilities of aerial vehicles, wheeled vehicles, and tracked terrestrial vehicles, where they're just not able to navigate a site like that. So what you're trying to do is you're trying to put sensors, or to get sensors and perceive your environment on some kind of mobile system that has to be able to navigate these dynamic environments. And that's really where legs came in. So I think that Spot is an incredible and miraculous technology because, for the first time in those environments, we're able to add value. But, we're seeing that value in lots of industries as well.
So I'm curious about what is your aspiration, maybe in being post-time, what your aspiration you have?
My aspiration, let's see.
Yeah.
I mean, I really believe that there will be a fundamental change to the way that construction projects are delivered in terms of being on time, on budget, and more efficient, that will be driven by robust data capture programs.
And which book inspired you? Do you think was very inspiring too?
Oh goodness. I've read all sorts of interesting books. I'm an avid reader. There are a lot of interesting books that aren't specific to construction that I think have kind of guided my thinking. There's an interesting one that I read that was really interesting to me in college called War in the Age of Intelligent Machines by Manuel de Landa. A lot of it focused on military technology, but there's a bit in the beginning about a concept of the robot historian. And part of it is a kind of post-human idea that knowledge, or the production of knowledge and the perpetuation of knowledge in the universe, is not specific to humanity. It's something that can be passed along to other systems like robots. And I found that to be a very powerful idea. For me, it's more of a synergistic relationship between humans and robots. So this was kind of an extreme metaphor illustration of how it could be done entirely without humans. So I think thinking about the production of knowledge and the sharing of knowledge between human and machine systems really originated with that reading. And I think jump cut to today and thinking about artificial intelligence systems and how to better encode human intent. I think I'm reading Human Compatible, which is a book by Stuart Russell. And it's really about how to encode human intent into AI systems, which is to say, can we get better about describing the utility value, the functions, what is the desired outcome of machines and AI systems? A really interesting example given is even bad algorithms, not super advanced AI, have led to unintended consequences. You think about the click-through algorithm of Twitter. Essentially, you could argue led to the political turmoil we're seeing today and the radicalization of a lot of people. And that was just an algorithm that was really meant to make people click on ads. But instead, what it did was it realized that the more polarized your beliefs are, the more likely you're to click on things. So it kind of drove that polarization. That is not how that algorithm was designed, but that is how it was manifested. So that's a very specific example. But if you think about the fact that these algorithms and AI processes are getting, more and more advanced as we move into the future, we need to do a better job of taking control of what the intended outcomes are and better defining that and not loosely designing the systems and allowing that to kind of be up to the algorithm to figure out.
Sounds interesting, yeah. So thanks for this suggestion for this for this book. Thank you. And what could be the most important quality you have gained while being working in as a part of Boston Dynamics? What most important quality you have gained and you have to maintain?
I think this is the best place in the world to work just because of how curious everyone is about the world, right? We are introducing something that is very new to the world, and we all are really excited about the possibilities for that, and we also take that responsibility very seriously and want to make sure that it's done right and that it's done under the advisement of our customers who are the experts in their industries, right? So we know our role, which is that we are experts in these highly dynamic robotics, but to make them truly useful, we have to have a true collaboration with industry.
And lastly, what was the best advice was given to you and was a life changing?
One of the things is that I try to do, I don't know if I'm sure that this is a hard question because you get good advice from thousands of people over the course of your lifetime. There isn't like a pivotal turning moment for me, but I think that just generally not being over constrained by your discipline and being open to new opportunities So, I mean, the example of that is I was educated as an architect. I was really passionate about design and architecture, but I saw these opportunities to have what I thought to be a greater impact by exploring working in construction, by exploring joining a vertically integrated company versus a traditional architecture practice, and ultimately by joining a robotics company. So somebody who gets an architecture degree doesn't typically do that, and just trusting that those instincts are right, and also staying humble and kind of learning from your peers around you. But I think that kind of hybrid specialization and collaboration with lots of different disciplines working together is ultimately what leads to more interesting impact on these industries.
Yeah, that's also wonderful advice. I think this is something relatable for maybe people changing passes or maybe different, getting out of their comfort zone. So I think that's relatable advice. And do you have any final words you would like to say for robotics community? Any final words you would like to say?
Just that I think this is a really exciting time for robotics. I think that we all know that this is the future, that this technology is eminently achievable. There's still quite a few hurdles to overcome, and I think that's okay. I think it's okay to take time to think through these problems, and to do this the right way. So, have faith that there will be these breakthroughs. I think we're going to see some huge growth even over just the next 5 years in these industries, partially driven by the changing world around COVID and the need for more robotic solutions and kind of remote access solutions to environment. But it's okay to also take time, think through these problems, and solve these things the right way. And I think a lot of that just comes from conversation with the end users and understanding their needs.
Yeah, indeed. So yeah, thanks so much, Brian. It was such a pleasure and honor to have you on the podcast. And yeah, keep up the good work. And thank you once again for joining. Thank you.
Thank you so much for having me.
Thank you.